we're going to switch gears a little bit and talk about the binomial theorem. Excuse me. So if I asked you to expand a plus b to the power of 2, it's this expansion of a binomial. We could FOIL this out. So this is the same as saying, oops, a plus b times a plus b. And if we FOIL it, I'm going to get a times a, or a squared. Our outer is going to be a times b, or plus ab. Our inner, again, a times b, plus ab. And our last is b times b. So this becomes a squared plus 2ab plus b squared by combining the middle terms. And we have just performed the binomial expansion of this. Okay. Now if I ask you to do this, that gets a little messier, right? Because now I've got, this is not just something like a to the 6th plus b to the 6th. Do not do that, please. All right, it all has to be FOILed and distributed. So I would have to take this. This is a plus b squared, and I would have to take that and multiply it by another a plus b. Oops. Okay, you get the idea. And I would distribute that out, and let's see what we'll get. I'm going to distribute a to everything here. I'm going to get a cubed plus 2a squared b plus ab squared, and then I need to distribute the b in. So I'm going to get plus b times a squared. I'm going to write it as a squared b, just keeping everything in order. It helps us to line up and see the like terms. Plus b times 2ab is 2ab squared. B times b squared is plus b cubed. Now I can combine like terms. I'm going to get a cubed. I've got a squared b and a squared b, so that's plus 3a squared b plus 3ab squared plus b cubed. And that's equal to a plus b to the 3rd power. Okay, I wanted the 6th, so we'd have to do this 3 more times. This is going to get long and involved and messy, and there are some shortcuts for doing it. So let's go take a look at the binomial theorem. That's what that's helping us with. Okay, binomial theorem tells us about ways of expanding powers of a binomial. That's what we were just doing. Okay, now the coefficients are what's important here. Okay, notice that I have a list here of expansions of binomials, x plus y to the 0, x plus y to the 1st, x plus y squared, which would be just FOILing this, cubed to the 4th and to the 5th power. In each expansion, there are n plus 1 terms. So n being our exponent. So notice here there are x plus y is 2 terms, exponent of 1. There's one more term than there is the exponent. Also notice that the powers of x decrease and the powers of y increase as we move from left to right. So if we start out with, we have x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, and finally x to the 0, or no x at all. Notice that they go down, and if you look at the exponents on the y, they start at 0, 1, 2, 3, 4, 5, they go up. Okay? Okay, sum of the powers of each term is equal to n, and the coefficients increase and decrease in that symmetric pattern. Okay. So we're going to introduce one way of calculating the coefficients, and it's using this combinations formula. Remember that factorial means, for example, 4 factorial is 4 times 3 times 2 times 1. Okay, and so n is the the power of your expansion. There it is. Okay, and r is the number of the position of the y. So if it's y to the r power, this would be x to the n minus r and y to the r. And we'd calculate the coefficient using this formula. Let's try practicing a little bit. Just note that the syntax, these two syntaxes are identical. They mean the same thing as far as calculating coefficients of binomials. So let's find each binomial coefficient here. Well, 8c2. Okay, that's where n is 8 and r is 2. So this is going to equal 8 factorial divided by 6 factorial times 2 factorial. Okay. And remember the formula. I'm just going to jot it up here. NCR, which is the same as NR, is equal to n factorial over n minus r factorial times r factorial. Okay, that's what I did here. Now, we could multiply this all out, or we could do some cancellation. I'm going to expand it for illustration purposes. This is 8 times 7, oops, 8 times 7 times 6 times 5 times 4, 3 times 2 times 1, divided by 6 times 5 times 4 times 3 times 2 times 1 times 2 times 1 again for the 2 factorial. Now, if I look at this, there's a bunch of stuff that I can cancel. Okay, 6 cancels with the 6, the 5 with the 5, 4 with the 4, and so on. And I wind up with 8 times 7, which is 56, divided by 2 times 1 is 2, or 28. So that would be the numeric coefficient of that term in the binomial. Okay. Let's take a look at another one. 10(3). This is going to be 10 factorial over 10 minus 3 factorial, or 7 factorial times 3 factorial. Okay, and I'm not going to expand. I'm not going to write it all out, but we could the 10 and the 7. Anything less than 7. This is 10 times 9 times 8 times 7 times 6, blah blah blah. The 7 times 6 times 5 times 4 times 3 times 2 will cancel out with this one. So I could write this as 10 times 9 times 8. Everything else will cancel with that 7 divided by 3 times 2, which is the expansion of 3 factorial. I can actually cancel the 3 with the 9, make that a 3. And I can cancel that with that, make that a 4. So I get 10 times 3 times 4, or 120. Let's keep going. Let's do 3c0. It's going to be n is 3. N minus r is 3 minus 0 times 0 factorial. Well, 3 factorial over 3 factorial is 1. What is 0 factorial? Well, that's defined to be 1, so this is just 1 over 1 or 1. And 8 is going to be 8 factorial over 8 minus 8 is 0 factorial times 8 factorial. And again, that's equal to 1 if you work it out. Here's a little shortcut. Once you realize the factors that cancel and everything, you could write these out this way. We could write this one as 8 factorial divided by 8 minus 2, 6 factorial times 2 factorial. What's going to happen is the 6 factorial gets canceled with the portion of the 8 factorial, right? Because that's 8 times 7 times 6 times 5 times 4 times 3 times 2. Okay, the last 2 times 1 is this 2 factorial. Now this can all cancel 6, right? Just like we did before. Okay, and you're left with just 8 times 7 in the numerator and 2 times 1 in the denominator. So this is just a shortcut if you want to remember these ways of doing it. That's fine. So I'm just going to do one of these. 7, 3 is going to be 3 factors from the 7 factorial. So it's going to be 7 times 6 times 5 over 3 factorial. 3 times 2 times 1. 3 times 2 cancels with the 6. And I'm left with 7 times 5 divided by 1, or 35. Okay, and I'm going to take up Pascal's triangle in the subsequent video.